Other people don't. It's okay. I'm used to it. So, Chapter 5, root locus analysis. This is what we've been building toward. When we started out, we were like control systems, feedback. This is the idea, make that error to 0. And then you're like, how 0 though? Like in time, like at the end of time it could be 0, or like it needs to be 0 soon. How does it go to 0? Does it need to be 0, or can it just be small? Does it really have to go to 0 at all? Maybe it could just go off to infinity and that would be fine. And that's what we dealt with in our chapters 2, 3, and 4, the performance criteria. So first we were like, yeah, it's got to be stable, so it can't go off to infinity. Okay, that was one criterion that we had. And then we also said, okay, we're going to have some criteria for how it goes to the steady state value. So in time, like there's like the overshoot, there's like the amount of time it takes for it to respond, the rise time, and then there's the settling time, the time it takes to get close to the final value. And then we said, okay, that's like the transient stuff. Peak time was another one. And then we said, okay, what about in steady state then? That final value, like how do we evaluate if that's good or not? Is that final value what we want? And we learned how to actually get rid of steady state error was to add integrators in there, right? To include integrators in there, I should say. And that was our 3 chapters. So chapters 2, 3, and 4 we're covering those performance criteria. And now we're going to get to root locus analysis, which is going to be the foundation of our tool to design control systems. So root locus design is chapter 6, and that's what we're finishing the course on. So root locus is where it's at. We've got to build up the analytical tools first, and then once we've got the definitions and the like a concept of how to sketch a root locus, then we can use it as a design tool in the next chapter. Okay. And we're going to continue to look back at performance and be like, okay, I want this performance. I'm going to use this root locus technique to get the performance that I want. So the root locus is a graphical technique for designing for closed loop transient response from open loop knowledge and some cleverness. A system's transient response is dominated by its poles. Okay? Zeros also have an effect, but the poles are the dominant effect in the transient response. For a system with feedback, solving for these closed loop poles is challenging, as we will see in the next lecture, in 5.1. Due to the use of complex analysis in this chapter, it is recommended that the reader review lecture A1 before proceeding. So we'll review it, and we'll go ahead and do so in just a moment, and then we'll proceed with this chapter. Any questions about the broad strokes of what we're doing here?